Hello, and welcome to lecture 11, part 1 for Life in the Universe. In this lecture, which is the moment I'm planning 3 parts, we'll take a look at Unit D, which is primarily about the history of life on Earth. A little bit about the future as well. One thing that I have only recently remembered is that PowerPoint has this feature where I can basically use a pen to do a markup, like the little scribbles you see me making over on the right there. And I realized this might be better than just trying to use the cursor to point at things when trying to draw your attention to something in the slide. So I'm going to use that for a few videos. And anyway, if you prefer the this pen feature, let me know. If you'd rather I went back to using the cursor, let me know. I suspect most of you will probably be all right either way. All right, well, since this is the first video in the lecture, there's an alien of the lecture to tell you about. And here's another one from the Star Trek universe. This is a Cardassian, not to be confused with a Kardashian, which is a very different thing. The Cardassians were introduced in the Next Generation series and were prominent in Deep Space Nine. And 4 actors in makeup. I think it's actually a pretty good thing. They did actually quite a lot with the makeup, besides the prosthetics and giving this kind of scaly-like structure. One thing I kind of particularly like is the neck structure here. Just by putting those prosthetics on, they kind of broke the outline a little bit and made them look not quite so human in their outlines, and that was kind of good. Anyway, the Cardassians were primarily antagonist to the Federation in Star Trek. At the time the series is taking place, they have a military dictatorship government and kind of an interesting legal system. You know, at least the principle in ours, that you're supposedly innocent until proven guilty of criminal charges. And the Cardassian system, you're guilty, period. They still have trials, but the purpose of the trial is not to determine innocence or guilt, but to determine what it is you are guilty of. And apparently, Cardassian literature included mystery novels, where again, the point wasn't to determine which character was guilty, but what characters were guilty of what. All right, anyway, I'll have a link in the description if you want to go listen to soundtrack from the Deep Space Nine TV series. Okay, now, so what we're doing in this unit is we're taking a look at the history of life on Earth. And our motivation for doing this is to try and get some idea of how life in general might originate and develop. And there's a potential problem with this approach, namely that the Earth is the only inhabited planet we know about. We also have an advantage. We know more about early conditions on the Earth than any other planets, but the main thing here is that it's the only planet we know for sure is inhabited. So it's our only sample. But a sample size of 1 runs a big risk of being extremely atypical. The Earth may be very atypical for planets of its particular size. Planets of the size may be atypical in terms of how life originates and develops. In general, it might happen very differently at a very different rate than it did on Earth. We don't know, nor can we know until we can find some more inhabited planets. And in fact, we can't actually be sure that life on Earth originated here. And let me try and explain this. So we have a few dozen meteorites that, rather than being asteroidal in origin, are from Mars. And we can tell that from the mineral composition of these meteorites. And in particular, some of them have little pockets where there's bits of Martian atmosphere still trapped inside. And apparently the way they got here is a large asteroid or comet impact on Mars can knock some of Mars's crustal rocks into space, putting them on orbit around the sun. And some of those orbits will eventually intersect the Earth, and if they're not too big, they can survive falling through our atmosphere to reach the ground as meteorites. And the thing is, there's some indications that it's probably plausible that sufficiently hardy microbes could, encased in one of these meteorites, survive the trip. So it's possible that life in the solar system originated on Mars, and some Martian microbes made the trip here and were the beginnings of life on Earth. And a very intriguing idea, because if it's true, the Martian invasion has already happened and it's us. But if it is true, it's going to be very hard to show it. The only thing I can think of is that might be indicative of it if we ever find that there is or was Martian life and can show there's a biological relationship between that life and Earth life. Probably, well, except for traveling on our spacecraft, it would be easier for Mars to get here than an Earth flight to get there on meteorites. Now, one thing I want to ensure you is that considering a natural origin of life, and natural things are the only things that science can actually examine, but assuming that but a natural origin of life does not imply that all these complex molecules involved in biology that we talked about in the last unit, or that organisms are assembled just by throwing the parts together at random. Not at all. The point is that given the proper initial ingredients and conditions, these complex molecules and eventually organisms would then follow as the result of deterministic chemical and physical laws. So it's not an issue of having to try and assemble, say, an insulin protein at random. All right, now, one problem we have is the conditions under which life might arise, and once it's there, survive or even thrive, are rather poorly known. And Earth, at best, gives us lower limits on the conditions under which life can exist. We know life can exist in certain conditions on Earth. Maybe the conditions are wider. And one thing that's encouraging is these organisms we call extremophiles on Earth that basically give us an idea that probably anywhere water is liquid, life might at least be plausible. This is a picture of something called Prismatic Lake. I think it's in Yellowstone National Park. It's in one of the national parks. And very, very high sulfur content in this lake, which is basically sulfur containing and using bacteria is what makes all this really colorful stuff all around the edges here. And anyway, you can see the steam coming off the lake. Because of geothermal heat, this lake is nearly boiling. You wouldn't live very long if you went swimming there, but there are plenty of microorganisms that love it there. Now, we are not yet at the point where we can make a living organism from scratch in the lab. Scratch is a very versatile ingredient. You can make biscuits from it, pancakes, cakes, chili, a lot of things you can make from scratch. Although whenever I go to the grocery store, I can't figure out what aisle scratch is in. But anyway, what I guess we should say, we have not successfully built from the raw ingredients a living functional cell. A simple bacterium would presumably be the first step there. But we have constructed viruses from the raw ingredients in the lab. If you consider them living, then we have produced organisms in the lab. If you don't, we haven't. But there's a lot of work that we do in the lab, trying to figure out various things that might have happened along the way to the origin of life, and giving us a lot of ideas, showing us some things that probably don't work, giving us some good ideas, some plausibilities. But the point is, if you want to, even if we never practically succeed in making a bacterium in the lab, that wouldn't necessarily be an indication that it couldn't happen, because even if it happened fairly quickly in geological and astronomical terms, remember, the Earth is an entire planet and would have had millions of years in which to do it. And compared to the laboratory space and research time that humans are ever going to be able to put into it, the Earth had a lot more time and space to get it done. So even a relatively unusual event becomes fairly likely if you've got a big enough space over a big enough time. Now, here are a few things we know about the early Earth. The Earth and the rest of the solar system formed a little bit more than 4.5 billion years ago. Right here, this abbreviation stands for gigayears. G, the prefix giga, stands for 10 to the 9. So that's a billion. So if you need to write billion years, that's a good short way to do it. Anyway, by about 4.4 billion years ago, the Earth's crust had apparently solidified, probably had some liquid water on the surface and at least an early atmosphere by that time, although one quite different from the one we have now, as we will see. And it's also apparent that the terrestrial planets underwent what we call a late heavy bombardment period, late only in terms of time scale of solar system formation, not in terms of solar system history. A period of big impacts between about 4.2 to about 3.9 billion years ago, possibly related to orbital migration of the Jovian planets, which is something we'll get to when we talk about formation of planetary systems in unit H, I think. We'll see. Anyway, one reason we know this heavy bombardment apparently happened is by looking at the surface of the moon. And the so-called lunar highlands, which are these more lightly colored regions, just circled parts of them, here that are very, very heavily cratered, basically saturated with impact craters. Whereas the darker Maria, like this one here, have a lot fewer craters on it. All right, so we know from rocks brought back from the moon's surface from both the Maria and the highlands. So Maria and highlands here. Hey, those are even legible M's and H's. Anyway, we know the rocks in the highlands are older. And the thing is, all geological processes that we'll talk about in some unit in a few units from now, other than impact cratering, will tend to destroy impact craters. So if you see a very heavily cratered surface, you know that not much has happened to it since those craters formed. And the rocks brought back from the highlands are over 4 billion years old. Maybe mostly kind of 3 to 4 billion years or older the ages, the ones from the Maria. They're younger. But whatever processes happened to the Maria have removed whatever craters might have been there. We'll talk more about that later. All right, now we're going to see this particular figure quite a lot in this unit. So this is some major episodes of the history of life going in Earth with, where's my thing here, with time increasing as we go from upwards. So we're right here at the top. The 0 is now, and then this is how many millions of years ago. So if you want it in billions of years, divide by 1,000. So that's 500 million years ago, 1.5 billion, 2.5 billion, 3.5 billion, 4.5 billion, and so forth. And anyway, so we're kind of in this period down here. And the point is, during the heavy bombardment period, it would be extremely difficult for life to live if it started, because some of these impacts would be basically sterilization level events. And during the heavy bombardment, if you can't live in a magma ocean, life's going to be hard. So there's a good chance, not guaranteed, but there's a good chance that any life originating during the heavy bombardment period might not have survived out of it. It's also possible life originated more than once on Earth. Okay, but anyway, we'll get to that in the next video, more about the origin of life. So for the attendant secret code, I was inspired by this today because of yesterday I went to the dentist, and this is a heavily distorted galaxy. It's gravitationally interacting with some other nearby galaxies. But because of the shape of it and because of this foreground star right there looking kind of like a headrest, this is nicknamed the dentist chair galaxy. So the idea is, I guess, the patient would be sitting in the chair kind of like that. So anyway, there is, I thought of this because like I said, I went to the dentist yesterday, the day before I recorded this. So anyway, dentist chair galaxy is our attendant secret code for today. And now that I'm using that pin, it gives me this little message, and I get a really loud error message in my headphones when I do that, which you're not hearing. All right. Well, anyway, I will see you in the next video, where we'll take a little bit more about plausible ways in as to which life might have originated on Earth.